Welcome to today's lesson. This is your chemistry teacher, Mr. Mavote. Not forgetting to like our page, to subscribe to our page, and to comment on our website. Today we are going to talk about changes in state. This lesson we are drawing it from the lesson which we had yesterday, where we talked about the three state of matter. If you remember, we talked about a liquid, we talked about a gas, and we talked about a solid. We even discussed on how we can differentiate them using shape, using the volume, compressibility, and their movement, and the way they are arranged, or the way particles are arranged. Now, some substances, they are able to change from a solid to a liquid, from a liquid to a gas, and vice versa. Some are also able to change from a gas to a liquid, from a liquid to a gas. And what makes them to change? So this is what we want to discover today. So what makes them to change is what we call changes in state. In chemistry, we have two types of changes. There is what we call a physical change, and there is what we call a chemical change. If one happens to ask you, how different are they? A chemical change, this is a change that cannot be reversible. Any change that takes place which cannot be reversible is a chemical change. Any change that takes place which is reversible, that is a physical change. So the change that we are going to talk about today, it will be more of physical and a bit of chemical. Now, what happens for a substance to change physically? There are two things involved. It's either this substance should be heated or the substance should be cooled. Meaning, when you heat the substance, it is now changing from a solid to a liquid, from a liquid to a gas. And somewhere we are going to discuss about the heating curve. So the heating curve moves hand in hand with the heating effect. Then when a substance is being cooled, it means it is changing its state from a gas to a liquid, from a liquid to a solid. We are cooling this substance, and this is now what we call a cooling curve. Okay, so let's see what takes place under heating and its effect. For example, maybe someone happens to ask you to say, what is involved in heating? What is involved in heating? In heating, this is when we supply heat to a substance. This is when we supply heat to a substance. And when a substance is heated, it means it is changing its state from a solid to a liquid, and from a liquid to a gas. When this process is taking place, according to the kinetic theory of matter, it means the particles themselves, they are moving slightly further apart. Remember where we are coming from. We talked about particles in solids being closely packed. And when heating is done, it means these particles, that cohesion force which holds them, it will be broken down, and then particles will start moving further apart, and then from there a change of state will take place, and the substance will change from a solid, it will no longer be a solid, but now it will be called a liquid, and from a liquid it will change to a gas. Let's move on to effects of heating. Definitely, when heat is applied, there are certain changes that are going to take place. And now these changes, they are the ones that we refer to be effects of heating a substance. One of them is called melting. One of them is called the melting. How do we define melting? It is a change of state from a solid to a liquid. Whenever a substance is changing its state from a solid to a liquid, then we say this substance has melted. And at that particular point where melting takes place, that is what we call a melting point. That is what we call a melting point. Uses of melting. What do we use melting for? It is used for cutting and shaping of metals. It is also used for welding. The common use, it is welding. I don't expect anyone to forget welding, because this is a thing that we always see nearly every day. So melting in an industry, it is used for welding, or it is used for cutting metals. It is used for cutting metals. So that's what is there on melting. So a substance will change from a solid to a liquid. A substance will change from a solid to a liquid. And that particular temperature where a substance changes, that is what we call a melting point. That is what we call a melting point. We move on to number 2. Number 2, we have evaporation. Evaporation, this is a change of state from a liquid to a gas. The change of state from a liquid to a gas. Don't forget, these are examples of physical change. If at all you happen to come across with a question which is saying, give me 2 or 3 examples of physical change, you can pick melting, you can also pick evaporation. They are a very good example of physical change. Why are they a good example of physical change? Because under physical change, a substance is reversible and no new substance is formed under physical change. Remember, when a substance is changing from a liquid to a gas, we can give a very good example. When women are cooking, you put water in the pot and you put your pot on the stove. If you want, leave the water on the stove for 1 hour or 2 hours and see what will happen. When you come back, you will not find your water. It will evaporate, meaning it will no longer be a liquid, then it becomes water vapor in the atmosphere. If you had covered your pot and then you remove your lid, you discover that the water had condensed on the lid. When you lift the lid, you see some water drops. That is a very good example of physical change. The water boiled, it evaporated, it found a lid, it couldn't escape. It bounces back, it condenses, it comes back in the pot. That is a very good example of a physical change. Let's see what happens on evaporation. We are saying evaporation is a change of state from a liquid to a gas, and a very good example that we used was water. So even here the writer uses water, a liquid which has been heated and then it changes to a gas, which is water vapor. Let's go to uses of water vapor. Why do we use water vapor? Water vapor is used in drying clothes. Evaporation. We're talking about evaporation. I don't know why I figured out with whatever. Uses of evaporation. It is used in drying clothes. Meaning without evaporation, clothes will not dry. Meaning clothes will not dry. It is used in obtaining crystals from solution. Crystals like sugar crystal, salt crystal, even the same sweets that we normally eat. Those are a very good product of evaporation. Remember, like sugar, it comes from sugarcane. They crush the sugarcane, that's a liquid. They keep on filtering it and heating it until it becomes a very big crystal, which they will grind, and then you have the sugar crystals which will come out at the end of the day. So those are some of the uses of evaporation. I remember there was a question, I've just forgotten which year was that one. Let me try to check. Could it be 2024? No. 2022? 2023. Okay, yeah. So here we had a question which was obtained from evaporation. Look at this question. Use the knowledge of the kinetic theory of matter to answer the question that follow. Explain why an inflated balloon which is pressed in a refrigerator slowly starts to shrink. With reference to any changes, what type of process is this? Explain why wet clothes dry on a warmer day than on a colder day. So this is the question that I was much interested. C. This is a past paper for 2023 GCE. Explain why wet clothes dry faster on a warmer day than on a cold day. Let's go back to our lesson. What are we talking about? We discovered that one of the uses of evaporation is that it is used in the drying of clothes. So when answering that question, you should know to say, where is this question coming from? It is coming from this subtopic, uses of evaporation. It is used in drying clothes. When answering it, what should you figure out? Answering it, you go to the factors that affect the rate of evaporation. One of them, it is surface area. Second one, it is wind current. The third one, it's humidity. The fourth one is the temperature. The question is talking about warmer day, so your answer should come from temperature. When the temperature rates are high, it means even the rate of evaporation will be faster. Hence, clothes will dry up quickly on a warmer day than on a sunny day. So temperature, it is in direct proportion. The higher the temperature, the faster the rate of evaporation. Then humidity, it is the one which is the opposite. Remember the definition for humidity? It is the amount of water vapor in the atmosphere. The amount of water vapor in the atmosphere. Meaning the higher the humidity, the lower the rate of evaporation. The lower the humidity, the higher the rate of evaporation. When humidity is very high, it means evaporation will be very low. Wind current, the higher or the faster the wind, the higher the rate of evaporation. Surface area, the larger the surface area, the faster the rate of evaporation. So these are some of the factors of evaporation. At least you've seen how a question normally come on evaporation. That was my major interest. The other part, I would want you to differentiate or to state the difference that is there between evaporation and boiling. Some people have been mixing the two. Evaporation occurs at any temperature, then boiling occurs at a specific temperature. I even forgot, under evaporation, that is where you find a boiling point. That's where you find a boiling point. The temperature at which a liquid changes into a gas, that is what we call a boiling point. For example, like water. Generally, we say water boils at 100 degrees, meaning that's the boiling point of water. We say ethanol boils at 78. That's the boiling point of ethanol. Okay, then the other difference, which I don't expect you to forget, under boiling, we normally see bubbles. Okay, under boiling, we normally see bubbles. If the water is boiling, you see bubbles. But under evaporation, you will not see any bubbles. You just discover that your water has finished without knowing where the water has gone. And the other one is that evaporation occurs slowly. Okay, whilst boiling occurs rapidly. It's a quicker process. In few minutes or in few hours, your water can finish under boiling. But under evaporation, it's a process. A good example, it's the dam. Even our Victoria Falls there, the last time when I visited there, it looked as if it was dry. Okay, the reason is that evaporation takes place every day, but you cannot see and you cannot notice that evaporation is taking place. Let's go to sublimation. Sublimation is referred to be the direct change of a state from a solid to a gas by heating. It means a substance has sublimed. It means a substance has sublimed, and that process is what we call sublimation. Other books, they say when a substance is changing from a gas to a solid and from a solid to a gas, it's sublimation. But in other books, we call it redepositioning. Redepositioning, meaning the substance is brought back to its normal state where it was. Examples of substances that sublimes. Examples of substance that sublimes, we have iodine, ammonium sulfate, ammonium chloride, and carbon dioxide. So these are some of the substances that are able to sublime, meaning they are able to change from a solid to a gas or from a gas to a solid. So for today, this is where our lesson ends. In our next lesson, we'll talk about the caves. We'll talk about the heating cave and also talk about the cooling cave. Thank you very much. Enjoy your studies. I'll post the homework for today, which will be based on what we have learned. Thank you and take care.